Okay, so let's look at intersecting graphs. Let's say we have two functions, okay, f(x) equals x squared, so that's a quad, and g of x equals x plus 2, that's linear, or i.e. f of x equals x squared, that's the same as y equals x squared, g of x equals x plus 2, that's the same as y equals x plus 2. Okay, so let's say we plotted the linear function, y equals x plus 2, and the y equals x squared, the quad. You can see that they intersect at 2 points. Okay, and from the graph you can just read off where are those points of intersection. Okay, and that's those there. But you could also find the points of intersection by equating one to the other. And we did this before with the linear ones. So we let x squared equals x plus 2. So x squared minus x minus 2 is all equal to 0. So the factors of that new function or equation are x minus 2 and x plus 1. If we let those equal to 0, we'll see that our x values are 2, which is here, and minus 1, which is here. Okay, so we can solve f of x equals g of x, which is what we've done there by equating these two, by solving f of x equals g of x by equating them, by plotting both points and noting the x values of the points of intersection. Okay, so they are the x values of the point of intersection, and we could put those back into our equations to find the corresponding y values. So for here we have x equals 2, so y is equal to 2 plus 2 is equal to 4. And for this point here we have x equals minus 1, so we can plug in x equals minus 1 into either of the equations. It doesn't matter. Y equals minus 1 plus 2, but that's equal to minus 1. Or we can, sorry, is equal to 1, sorry, it's equal to 1. Minus 1 plus 2 is 1. Or we can put our minus 1 into the x squared function. It doesn't matter, because minus 1 squared is 1. Okay, the y coordinate. And we can also as well solve an inequality then where f of x is less than g of x, and basically that's those values of x for which the curve is below the line. Okay, so if we look at our graph here, f of x is less than g of x when x is greater than minus 1. Here it is below the line when x is greater than minus 1 and x is less than 2. Okay, so that's where the curve is below the line. That's the inequality there. F of x is less than g of x. Now let's look at maximum and minimum values. So, okay, so let's say we have a function that generates parabola like this. This is our axis of symmetry here, and this point here at the bottom of the parabola is known as the minimum turning point. Okay, and let's say that the coordinates of that minimum turning point here were the x value minus 1 and the y minus 4. Well, the minus 4 is the minimum value. Okay, it's 1, 2, 3, minus 4. Y equals minus 4 at that minimum turning point. And the 1 is here. X is 1, 2, 3, 4. X is 1 here. And actually, x is equal to 1. That's known as the equation of the axis of symmetry. So if you're given a curve and you know that this is x is equal to 7, and they say, oh, what's the equation of the axis of symmetry? It's x is equal to 7. And then don't forget that we can have parabolas this shape as well. This is not the minimum point, it's the maximum turning point, and that's still the axis of symmetry. Okay. What about finding f of k from a graph? Okay, so just bear with me a second. Okay, so let's say, let's just do it by example. Finding f of k from a graph. So let's say we have a function f of x equals x squared plus f of x minus 1, and that generates this parabola here. Okay, and let's say we're asked to find f of minus 4. So x is minus 4, so we come out here and we draw that line, x equals minus 4. We see where it cuts the parabola, and we go across and we get the y value minus 5. Okay, so f of minus 4, they're asking you what's that value of y when x equals minus 4. Okay, what is the value of y when x equals minus 4? And in this case it's minus 5. So here we go. To find f of minus 4, we draw the line x equals minus 4 and read the y value of the point where the line intersects the curve. F of minus 4 is equal to minus 5. Now, when is a function increasing or decreasing? Well, we can see that the curve of this parabola here slopes down before it starts to slope up again. And basically, if you think about it, the y values are decreasing all the time on this side of the curve. They're decreasing all the time. And then they start to increase on this side of the curve. They start to go up. So it's decreasing on this side and it's increasing the y, and the y values increase on the right. Okay, so the function is decreasing when the y value from x is minus 4, it's decreasing from there to x is 0, and it's increasing then from x is 0, the y value is getting greater when x is 0, 1, 2, 3, 4, 5, 6 to x is 6. Okay, question 8, page 468. F of x equals x squared plus x minus 6. G of x equals 3x minus 3. A quad and a linear. There they are plotted here. Use the graph to estimate f minus 2 and g of 3. So f minus 2 means we have to go out to x is minus 2, plot that line, see where it cuts, get the corresponding y value. And g of 3 means we have to go to x is equal to 3 and see where that cuts what's the y value of where it cuts the curve of the line. Okay, and in that case, for x is minus 2, y is minus 4, and for x is 3, y is equal to 6. Okay. Now, find the roots of f of x equals 0. Well, that's where the curve cuts the x-axis. So you just note this point and that point, x minus 3, x equals 2. Find the roots of f of x equals 4. Well, now we have to, this is like saying that y is equal to 4. So we go up to y equals 4, and we see where it cuts there and down and there and down, and it's these values here at which it cuts the x-axis. Okay, so for this case it's minus 3.7 and 2.7. That side. Find the roots of f of x equals g of x. Well, we just know from before that's the point of intersection. It's x equals minus 1 and x equals 3. So it's here. It's here. That's one point of intersection, and here's the other 3, minus 1 and 3. The roots being the x values. Okay, the x values. Minus 1 and 3. Okay, find the range of values of x for which f of x is less than or equal to g of x. Okay, so f of x less than or equal to g of x, that's these range of values from here to here, where the curve is below the line. F of x is below g of x, okay? And it's from minus 1 to 3. And the range of values where f of x is less than or equal to 0, and that's here to here, okay? F of x, or y, the y values. So it's from 3 to 2. Minus 3, sorry, to 2. Okay. What about quadratic graphs and real-life problems? Okay, so here's an example here, and the examples you'll meet with generally include the flight of a ball when it's thrown in the air, or maximising areas of fields of given parameters. Okay, well, let's look at this first. What we have graphed here is the function f of x equals 7 plus 5x minus 2x squared. So just notice how they've jumbled the function around, but it still is a quadratic function. In the domain minus 1 less than equal to x less than equal to 4. Use the graph to solve the function is equal to 0. So basically it's where it cuts the roots there, okay? X is -1, cuts the axis, sorry, and x is 3.5. Second part now. F of x is the height, so f of x, y, that's y, is the height, so this must be height, in meters reached by a particle fired from the ground at a point where x equals -1. The x-axis represents horizontal ground, and anything above it is the height. Okay. From the time of firing until it hits the ground again, the particle, so this is time here, was in flight for 4.5 seconds. Okay, so that was -1. So it's 1, 2, 3, 4. So that really should be around there, around 4.5. Okay. So find the maximum height. Find the maximum height reached by the particle, the height after 1.5 seconds, and the number of seconds the particle is 4 meters or more above the ground. Well, the maximum height is found there. Okay, wherever that is, the maximum turning point. The height after 1.5 seconds is found by drawing a line at x equals a half, because why is that? Because we've 1.5 seconds, well that would be at x equals 1. Remember, this is x, this is time at the 1. So 1.5 then, it'd be like there, okay? X is equal to a half. And you find where that cuts the curve and you get a corresponding height, it's 9. And to find the number of seconds the particle is 4 meters or more above the ground, we draw y equals 4, okay? It's y equals 4. And we note the x values where we're going from -0.5 to 3. Okay, so we're going from -0.5 here to 3. Okay, and -0.5 to 3 is 3.5 seconds. Okay, so just to remind you that, you know, the story there, that graph really is a height for y, time on the x-axis. F of x equals height, y equals height.